Hi, my name is Julia, and I'm going to talk about the function means modeling tool called Trinity. So when do we want to use a tool like this? Well, function means modeling is used to create functional decompositions of new or existing systems. This is done to gain an understanding of the system. That means we try to figure out what functions do we need to achieve in our system. What are the roles of the different components in the system? How do the different components interact? And we can use these results for different kinds of analysis, but mainly we're trying to build an understanding for how the system works. So this tool is divided into two sections. We have this canvas section here, where the tree lives, and then we have our side menu to the left. So I have loaded up a function means tree that I've built previously of a pair of headphones. We can see these darker nodes are the functions of the system, and these slightly brighter nodes are the means of the system. When we hover over a node, we get some different options. We have a plus sign here, which allows us to create new nodes underneath that node. You will notice that every other node is a function and every other node is a means. We also have these menus to the right on the nodes, which allows us to do some different things. For now, we will mostly ignore this, but it can be handy to know that this is where we delete a node if we create one that we do not want to keep. So to the left, we have our side menu, and here we can import existing models. We can switch views from this function tree view that we are in to, for instance, the DSM view, this design structure matrix view. We also have a compact view to get a more compact overview of the system. We also have different settings, and we have export options, allowing us to save our system either as a file that we can import later or as an image, or even as a DSM that you can open in Excel. Now, let's create a new system or a new functional decomposition. I want to make an example functional decomposition based on a coffee brewer. So typically when you run a functional decomposition, you have some kind of a reference product. So I will just use the coffee maker I have here at home. If you have your own coffee maker, then it's probably very similar to the one I have. So I'll use that as a reference. So the first thing we need to do is figure out what is the main function of our coffee brewer. Well, it's probably to brew coffee. And then we create a new node by clicking the plus sign, and we get a means node. So what means is required to fulfill this function of brewing coffee? Well, it's a coffee maker. Right. This is our main function and our main solution. And at this point, I want to mention that a function can only have one means by default. So if I try to create another means, I will get a warning that says axiomatic design mode is on. So a function can only have one means. This can be turned off over here, enforce axiomatic design. But I recommend, if this is just a regular function means tree, that you keep it on. Because having multiple means would mean that we have multiple variants of the design or multiple alternative designs in the same tree, which would complicate things quite a bit. So for now, let's keep it simple. We will now split this into multiple sub-functions. So what functions are required to brew coffee? Well, for instance, we somehow need to store the heated coffee that we have created. We need to keep the coffee heated. We need to store our coffee powder somehow. We need some some kind of a frame to contain all our parts. So I'll just say contain parts. And then we will have two systems. We will have a water management system, or manage water. We will have a power management system, so manage power. So now we have the functions that are required to brew coffee, and we will start associating means with these functions. So how do we store the heated coffee? Well, we have a coffee pot. We maintain coffee temperature using a hot plate. We store the coffee powder in a powder cone. We contain the parts using a chassis. And now we have the more complicated functions: manage water and manage power. These are quite vague. And I've done this on purpose because we will split this up into more sub-functions. So I will just put here, for managing water, we will have a water management system. And the same goes for power management. So starting with the water management system, and we can pan our camera by clicking on the canvas and dragging. We can zoom in with our mouse wheel, or if you're using a touchpad, you can just use two fingers and move it like this. So our water management system, we need to do at least three things with the water. We want to store it somehow, we want to heat it, and we want to combine it with the coffee powder. So for storing it, we can just use some kind of container. For heating it, we have some heating element. And for combining it with the coffee powder, we have some kind of a water transport system, which will again contain some sub-functions. We need to dispense the water into the powder, for which we will use a nozzle. We need to carry the water all the way from the container to the coffee powder. So we will you say carry water, and we will do that with some piping. And we need to prevent the water from flowing back into the storage container. So I will say that the third function here is to prevent flow back. And we will have a check valve to perform that function. Okay, that's our water management system. Then we have our power management system. So what do we need? Well, we need to somehow supply energy. We need to activate the brewing process, and we need some kind of a way to. Typically, coffee brewers have an automatic turn off, right? So we want to turn off automatically. For the automatic turn off, we will have a timer. For the activating the brewing process, we will have a switch, and we will supply energy using a cord to the wall outlet. All right. So of course you can keep zooming in, making more and more sub-functions, sub-solutions, but at some point you will run into a limit where further decomposition is no longer useful. So it's really up to you as a designer to when you want to stop. And for me, this will do. So I will not decompose this any further. So this is our coffee maker or coffee making system. If we at some point accidentally pan our camera way too much and we lose our way in this system, we can always just click this zoom to fit button up to the right. That will take us back to the tree. And yeah, now the system decomposition is done. So now we might want to save it. So we have this export option here in the side menu. You can click Save Data, and that will download a JSON file, which we later can import, if we want to, back into the Trinity software. And that covers the most basic functionality of Trinity, which is to decompose a system into its functions and its means. A more advanced functionality includes mapping out how these different components interact with each other, which we can use to create different types of DSM matrices, which in turn can be used for different types of analysis. But that's a little bit too much for one video, so I'll stop here.